Hey guys, welcome back. We're going to finish these two questions off, and I already started some scratch paper, so I'm just going to keep going from here. So question T59, suppose a high school student is randomly chosen from a large high school. The probability the senior is a senior is so the probability of a senior is 0.22. The probability that the student has a driver's license is 0.30. So you could think of it like this. Senior, not senior. Driver's license, no driver's license. Does that make sense? So if I had 100 kids in this school, I know that 22 out of those 100 are seniors, which means that 78 are not seniors. And I know 30% have their driver's license and 70% do not have their driver's license. Now it says, if the probability that the student is a senior or has the driver's license is 0.36. So it's saying the probability that the senior has the driver's license, or, remember, or is not picky. So that means I'm interested in thinking about this student because they're a senior, this student because they're a senior, this student because even though they're not a senior, they have their driver's license. So I'm interested in thinking about any of these three groups. I'm just not interested in that group. So that tells me if the probability of these three groups adds up to 0.36, then I actually know the probability that goes there. The probability that the student is a senior or has a driver's license. Okay, so let's find that out. 1 minus 0.36 would be 64. So out of 100 students at this school, 64 are neither a senior nor a driver's license, leaving that. Now I can work backwards using the complement rule. So 70 minus 64, I get 6. 22 minus 6, I get 16. 30 minus 16, I get 14. Now I can answer this question. What is the probability that the student is a senior and has a driver's license? Okay, so there's only one group here. It's these 16. So out of a total of 100, 16 are both a senior with a driver's license. 16 over 100 is 0.16. There's our answer, E. Awesome. Now, let's look at 15. So I'll just fold my paper to give me a little more room here. T 5.10. The security system in a house has 2 units that set off an alarm when the motion's detected. Neither one is entirely reliable, but one or both always go off. When there is motion anywhere in the house. Suppose for motion in a certain location, the probability that detector A goes off. Okay, so A goes off or A does not go off. B goes off or B does not go off. Okay. So it says, the probability that detector A goes off and B does not go off. So let's see if that makes sense. This would be A goes off, but B does not go off. This would be if both of them go off. So it says the probability that detector A goes off and detector B does not go off is 0.25. So I can put that 25 out of 100. The probability detector A does not go off is 0.35. So it merely says the probability that A does not go off. That would be not A. So that'd be 35. Now using our complement rule, we can kind of work backwards here. Okay. What is the probability that detector B goes off? Okay, well, they said in the very beginning, either both go off or one of the two of them. There's never a time when it doesn't go off. So we know that that is this scenario. That makes sense. There's never a situation where neither go off. Something always goes off. All right, so continuing to work my complement rule, I'm sitting here. Okay, worked my way back. There we go. Now let's answer the question. What's the probability detector B goes off? Well, the probability that B goes off is 75 out of 100. 75 out of 100 is 0.75. That's my answer. Thanks for joining us. See you soon.